The question is calculate the mass of non-volatile solute. Molar mass is given, which should be dissolved in 114 grams of octane to reduce its vapor pressure. What is given? Just you have to calculate the mass of solute, means W2 has to be calculated. M2 is given. This is actually M2. Okay, which should be dissolved in W1 to reduce its vapor pressure 80%. Means if you have P1 naught, P1 will be 0.8 P1 naught. Okay, Devanshi, fine. And it is talking about reduction in vapor pressure. Reduction in vapor pressure means lowering in vapor pressure, means relative lowering in vapor pressure. That formula you will be applying here. So you will be applying the relative lowering in vapor pressure formula, means P1 naught minus P1 divided by P1 naught equals to X2 obviously. So in this case, you can't neglect anything because it is 80% reduction. Sorry, 20% reduction. So you should not be neglecting anything. So it will be N2 divided by N1 plus N2. N2 you know. Sorry, N2 you can calculate. Given mass divided by molar mass. So it will actually be, if I write P1 naught minus P1, we have 0.8 P1 naught divided by P1 naught equals to N2 will be given mass divided by molar mass divided by N1 plus N2, means W1 by M1 plus W2 by M2. Now here W1 by M1 is very easy to calculate because in this case W1 is given 114, and if you calculate the molar mass of octane, it comes out to be 114, same thing. So you will actually get from here P1 naught minus 0.8, so it will be 0.2 P1 naught divided by P1 naught equals to W2 will be W2 we have to calculate. W2 divided by M2 is 40 divided by N1 will be 114 divided by 114. And the reason is W1 is 114 and molar mass of octane is also molar mass of octane when you calculate 114 gram per mole. If you write U, you can write U. But normally you should write gram per mole, and the reason is very simple. In few books it is written as U. Why I don't prefer writing U? Because here W2 is in grams. So if it is in grams, and the whole thing basically here in this particular case should come out to be mole. So it will be equal to mole if you have gram divided by gram per mole. Sorry, gram per mole. Only then gram will get cancelled and mole will go to the numerator, it will be mole. And this one will anyway be W2 divided by 40. So effectively you are saying 0.2 will be equal to W2 by 40 divided by 1 plus W2 by 40. Simplify, get the value of W2. That will be the mass of the solute to be added. Tanishi, you can take directly 20%. Okay, you can. Kasak, yes, it will be 10 gram. When you solve, you will get W2 equals to 10 gram. Easy question. And I would suggest in these numericals, always write what is given, what is required. Most of the times you will get the path you need to follow or the formula you need to use. Yeah. Next, a solution containing 30 grams of non-volatile solute exactly in 90 grams. So this one is, just a second. Gram of non-volatile solute. If it is solute, it has to be W2. Okay. Exactly 90 gram of water means this is W1. has a vapor pressure of this much. Now, because it is solution, this is not pure water. This is solution. It means P1 is given. This is P1. Further 18 gram. Now, this is the first case. You have W2 equals to 30 gram. You have W1 equals to 90 gram. And you have P1 equals to 2.8 kilopascal. And there should be second case. In second case, 18 gram of water is then added. Now remember, the solute is same, 30 gram. So W2 here in second case is still 30 grams. W1 now is 90 plus 18. That is 108 grams. And P1 becomes now 2.9 kilopascal. Now see what is asked. Calculate molar mass of the solute. When we say molar mass of the solute, molar mass comes into the number of moles. Molar mass comes into the number of moles. It looks I have already received. Okay, keep your mics off, everyone, unless you have to say something. Okay, so W2, W1, you have in first case pressure. What is the vapor pressure of the solution? You have. Then in second case also you have. So what you need to do, you just need to form two equations and get the answer. You just need to form two equations and get the answer from here. So in first case, you will apply the same formula. Are you saying something? Devyansh, your mic is on. Are you saying something?
No, sir, it's because of the fluctuation. Actually, the electricity is going in my area, so I don't know why.
Pranav, yes, molar mass normally will be given in board exam. Not in your school exams, I can't say, but in board exam, molar mass will be given. However, there is a shortcut also. Not I would say shortcut, but just you can apply some logic there. Suppose you have to calculate the molar mass of octane. Octane will have 8 carbons, and you see all hydrocarbons will start and end with CH3, right? In between, you will have CH2, CH2, CH2. So whatever you have, for example, it is a hydrocarbon, octane, nonane, decane, whatever. This will be 15, this will be 15. So you need to add 30. And how many times CH2 are there? Those many times you need to do 14. Okay. So for example, octane will be 30 plus 6 into 14. 114. 30 plus, here octane means 8 minus 2, 6 into 14. So it will always be molar mass of hydrocarbon. You can get very easily, very quickly, 30 plus n minus 2 into 14. You don't need to add all carbons or hydrogens, just 30 plus 14 into n minus 2. You can write it down. So from here, you will apply the lowering in vapor pressure, relative lowering in vapor pressure. So you will say P1 naught minus P1, that is 2.8 divided by.
So can you show the previous screen?
Previous screen. Previous screen, that was just temporary. I'm writing it again. Molar mass of any octane, any hydrocarbon is given by 30 plus 14 times n minus 2, where n is obviously number of carbons.
Okay.
So in first case, it will be P1 naught minus 2.8 divided by P1 naught equals to number of moles of solute, so it will be W2 divided by W1, and so it will be, I'm just writing, I should have calculated first N1 and N2. So N1 here will be 90 divided by 18, that is 5, and N2 here will be 30 divided by M. We don't know what is the molar mass here. Okay. This is M, we say it is M. So it will be here N2 divided by N1 plus N2. I'm just applying the formula. So it will be 30 divided by M divided by N1 plus N2, 5 plus 30 by M. That's what I'm applying, simple logic. Okay. Similarly, here I will apply P1 naught minus 2.9. Remember, P1 naught will not change. Sometimes you might say, why I'm using P1 naught at both places, because I have water, and water's vapor pressure will be same at a particular temperature. It will not change. Okay, pure water vapor pressure. So again here I will say P1 naught equals to, here again 30 by M, but here N1 will be 108 divided by 8. Water is 108 gram, means it will be 6. Yes, okay. So it will be 6 plus 30 by M. Now there is something which students are not able to do, and listen to me very carefully. In all such questions where you will find the answer by 2 equations from lowering of vapor pressure, you will always remember how to solve this. Because now if you divide these two, you will not get rid of P1 naught. We need to get molar mass. We need to get molar mass of the solute, means M, which I have assumed. M has to be obtained. M2 basically. Why I'm writing M2? Because it is of solute. So I'm just writing 2 to indicate it is solute. Now to solve these equations, these 2 equations are there. You have to rearrange them in a particular fashion always. Always. Okay. So what you will write? You will write this one, suppose, as 1 minus 2.8 divided by P naught, P1 naught, equals to whatever it is. Okay, whatever it is, 30 by M divided by 5 plus 30 by M, or M2. Here also you will write same thing, 1 minus 2.9 divided by P1 naught equals to 30 by M2 divided by 6 plus 30 by M2. I'm writing same thing. Now what you will do, you will have P1 naught at one side and M and everything else on the other side. So what you will do, you will move this on the right hand side, only this part, and this part you will move on right hand side, and this part you will move on left hand side. So this way only the P1 naught terms will be on the right hand side. So just keep writing, because I will be erasing what I'm going to write now. So just keep noting down. So it will be actually 1 minus 30 by M2 divided by 5 plus 30 by M2 equals to 2.8 divided by P1 naught. This will be the first equation. And second equation will be 1 minus 30 by M2 divided by 6 plus 30 by M2 equals to 2.9 divided by P1 naught.
Sir, in the first case, it would be M1.
M1, why?
Sir, in the first case.
No, it is M2. It is a molar mass of the solute in both cases.
Okay.
Okay. Molar mass of the solute, we have formed the 2 equations with the conditions given. So in both cases, this is the molar mass of solute. This is molar mass of solute, because this is the number of moles of solute, In one case, the vapor pressure is 2.8. In another case, vapor pressure is 2.9.
Okay.
right? So now you can simplify it. So when you simplify, you will take LCM 5 plus 30 by M2, or you can first write it 1 minus 30 divided by 5 M2 plus 30 equals to 2.8 divided by P1 naught. I hope you can understand what I am writing. At least this mathematics, you understand what I am doing. I am actually
Yes, sir.
multiplying both numerator and denominator by M2 here. I can do that. And here also I will be multiplying both numerator and denominator by M2 to get rid of the denominator. So here I will say 1 minus 30 by M2 divided by multiplied by M2. And here 6 M2 plus 30 equals to 2.9 by P1. Now I will simplify this part also. So this part I will take 5 M2 plus 30 as LCM. So it will be 5 M2 plus 30 minus 30 equals to 2.8 by P1 naught. And remember, this is the technique you will be following in all such questions. 6 M2 plus 30, 6 M2 plus 30 minus 30 equals to 2.9 by P1 naught. So 30 got cancelled. And 5 also you can divide both numerator and denominator by 5. So it will be M2 divided by M2 plus 6 equals to 2.8 divided by P1 naught. And this will be M2, 30 minus 30 got cancelled, divided by M2 plus 5 equals to 2.9 divided by P1 naught. I am dividing both numerator and denominator by 6 here. I am dividing both numerator and denominator here by 5. Now I can divide these two equations. Now if I divide these two equations, say this one is first, this one is second, then M2 will get cancelled and P1 naught will get cancelled. So I am doing 1 divided by 2. 1 divided by 2. Okay. So if I do 1 divided by 2, this will be in the denominator because 1 is considered first. So it will be M2 plus 6. This will come in numerator. Obviously, those who are not able to understand, not good in math, they have to do it. And it will be 2.8 by 2.9.
Sir, can you explain the 1 minus 30 by M2 step once more?
Are you talking about how I got this or simplification?
Yes, sir. How you got this?
Okay. Okay. So I'm just considering this one. Okay. Consider this one. I'm explaining again how I got it. Okay. My aim is to get M2 on one side and P1 on one side. The reason is very simple because at this moment here, if I divide this equation by this equation, then P1 naught and M2 will not get cancelled. Just to make sure that they get cancelled, what I can do, I can write this one as 1 minus 2.8 by P1 naught. And then I can keep this one either on left hand side or I can move this one on the right hand side. But I need to make sure that this term which contains P1 naught is on one side only. That's what I am doing. Okay, so I'm just explaining one. You can do the second one as it is. So I'm doing it here because otherwise I will have to use the temporary screen. I have not already created other screen for this one. So what you will do, you will write it like equals to 30 by M2 divided by, you have taken M2 as LCM. So it will be 5 M2 plus 30. Is that clear up to here? Shasha?
Yes, sir. Got it.
Then you will say, okay, 1 minus 30 by M2 into M2 by 5 M2 plus 30, because it is in numerator, when it goes into
Yes.
denominator, reciprocal will be there, equals to 2.8 divided by P1 naught. So it will be 1 minus 30 divided by 5 M2 plus 30 equals to 2.8 divided by P1 naught. Okay. Right. A 5% solution by mass of cane sugar. Cane sugar is normal sugar, C6H12O6. And the molar mass of cane sugar is 342. You should remember 342 gram per mole. Water has freezing point of this one. Calculate the freezing point of 5% glucose. Here it is glucose, C6H12O6, 180 gram per mole. In water, if freezing point of pure water is this one, even if it is not given, remember, you will not use the freezing point of water as 273. You will use 273.15. It has happened in past in JEE, students marked the one with 273 and the actual answer was based on 273.15. So here in this case, remember in both cases TF naught is same. Okay, so you have in first case delta TF equals to KF into 1000 into W2 divided by W1 into M2. Isn't it? Right? In first case. And what will be delta TF? Delta TF will be TF naught minus TF, means 273.15 minus what is of the solution, 271. This is delta TF. It will be equal to KF. And basically you don't need KF here. Otherwise of pure water, you know it is 1.86, right? But you don't need to write because it will get cancelled into W2. Now what you will say, 5% solution of cane sugar, you will say it means it is 5 gram in 100 gram of solution, right? 5 gram in 100 gram of solution. If you say 5% solution by mass, that is the point. Devyansh, no, that will not be the answer most probably.
Sir, I was writing the value of delta TF.
Okay. No problem. No problem. Okay. And then W2 you will write obviously 5 divided by W1. What will be the value of W1? Tell me. Write in the chat box. What is the value of W1? Good. Kasab, Pranav, Shashwat, Tanishi, think again. You applied correct knowledge, but the value is not correct. Devyansh, yes. Vedant, yes, but I am talking about the mass, not mole. Pratham, Devansh, yes. So it will be 95. Why I am telling you so? Because one student had written 95 and in your school exam, I think it was UT1. Last year, teacher deducted marks because she thought it would be 100. So you need to be careful that if there is any deduction of marks, you need to check whether it is done correctly or not. It will be here 95 because here we consider the mass of solvent only, not the solution. Into M2, in case of cane sugar, it is 342. Now, from here, you have everything basically. So you can calculate KF from here. Right? So what is the problem here? That if you insert the value or if you use the value of water as 1.86, you are not going to get the answer. And that is the trick here. That is the catch here, which you need to remember. So basically from here, you will get KF equals to something. And then you will apply it in the second case. In second case, you will say, okay, I need to calculate the freezing point. So freezing point will be actually TF naught minus TF. This is something I have to calculate. So TF naught will be same 273.15. It is same for water, but in solution, this will be different. So it will be equal to again same formula KF. Now KF I will be using from here. And when you calculate, this value will be approximately 14.7. Devyansh, okay, you have calculated 14.743. That might be exact one. I have just written here the approximate one. So it will be KF, that is 14.7 multiplied by 1000 multiplied by W2. Again, it is 5%, means it will be 5 gram, but now it will be 5 grams of glucose divided by W1. W1 will still be 95 into M2, and this will be glucose, so it will be 180. This is 273.15. So the only unknown is the freezing point, which is asked. Right now, initially, if you remember, I said that you can get answer by dividing. You can form two equations and you can divide. You can do that also, because in this case, many factors will get cancelled. And just listen to me how, and you will save time there. First, note down this one, and from here you can get the value of TF, and that will be the answer, and you will get 269 approximately Kelvin. Tanishi, normally you should have 2 digits. This is something I have replied in previous class as well. Someone asked, normally you should have 2 digits, but suppose your answer is 1 point something, okay, 1 point something, and there is nothing 10 to the power 3, 10 to the power 4, something like that, then you might consider it writing up to 3 decimal places. Or suppose your answer is itself in decimal, say it is 0.693. So don't write 0.69 because it is already nothing here. So write up to 3 places. So that is the thumb rule. If you have here 1 or 0, then you should use 3 digits after decimal. Otherwise, you can use 2 digits after decimal. Now, same question, but without calculating the value of KF and making the calculation simpler. What you can do, you can leave it as it is. Leave it as it is and form this equation. Say this one is first equation, this one is second equation. Now, if you divide these two equations, KF will get cancelled, 1000, 5, 95, 95, everything will get cancelled. So basically you will have this thing, which is there, 273.15 minus 271. It will be 2.15. Yes, 2.15. So this part 2.15 divided by this part 273.15 minus TF will be equal to this whole divided by this whole. Okay, here also you will write KF in that case. You don't know what is KF, okay? You will write KF. So this whole divided by this whole, basically everything will get cancelled except the molar masses. So because you are keeping this one is numerator and here it is in denominator, it will remain in denominator, and this one will be reciprocal of this one, so it will be 180. So I hope you are able to understand the mathematics I am talking about here. You are dividing 1 by 2, everything will get cancelled and you will get this simplified form. And now you can easily calculate why you saved time, because you did not calculate KF. So you saved time there. And then in equation second also, you did not do any calculations. Almost everything got cancelled. So this method is better. as compared to the previous one. And remember, when you calculate something and substitute in another equation, there are chances of some margin of error. Okay, so the answer might not be accurate one, because when you calculate KF, as I said, the value of KF approximately was 14.7. KF approximately 14.7. But suppose it is 14.71 and you substitute that value, you substitute 14.7 approximation, the answer will be slightly different from the actual answer. So always prefer cancellation. Any confusion here?
Got it.
Next one. Two elements A and B form compounds having formula AB2 and AB4. Two compounds we have, AB2 and AB4. When dissolved in 20 gram of benzene, means this is solvent, W1. 1 gram of AB2, W2, lowers the freezing point by this one, delta TF. This is the lowering, okay, depression in freezing point, delta TF. Whereas 1 gram means again W2, this is the solute now, okay, so it will be W2 for AB4, and it lowers by 1.3, means again delta TF, but for second case. So we are talking about two cases. We will form two equations, again we will divide and we will get the answer. Here it is asked, calculate the atomic masses of A and B. So we can get the molar mass of AB2 in terms of atomic masses of A and B. Similarly, molar mass of AB4 also can be obtained in terms of atomic masses of A and B. So I will assume the atomic masses of A and B. So I will say assume atomic mass or atomic masses of A and B are X and Y respectively. Then molar mass of AB2 will be A plus twice of B, and molar mass of AB4 will be A's atomic mass, it is once, and B is 4 times 4Y. So I got the molar masses of AB2 and AB4 in terms of their atomic masses. So obviously I have to get the values of X and Y. So I need to form two equations in two variables, and I need to simplify those equations. And for that, I know the formula for delta TF, because that is given. Delta TF is given. So if delta TF is given, and I have to obtain the equations in terms of X and Y. So instead of writing delta TF equals to KF into this, I will write in terms of M2. So I will write M AB2 will be, that will remain at the top. Yes, KF will remain at the top. 1000 will be there. W2 will be there. And here W1 will be there. But here delta TF. Okay, I have just rearranged. You can use this formula directly. Otherwise, you have here delta TF, you have here, and M you have here. So I have just interchanged it. So you will substitute the values. All the values you need to substitute. Okay. So when you substitute the values, you will get here, in this particular case, you will get X plus 2Y equals to KF, it is given 5.1, and 1000 into W2. W2 is 1 gram. In both cases, it is 1 gram. Whether it is AB2 or AB4, both are 1 gram. Divided by W1. W1 is 20 grams. This one into delta TF. In this case, delta TF is 2.3 in first case. Similarly, in second case, it will be MAB4 it will be Kf into 1000 into W2 divided by W1 into delta Tf in this case. So same thing I will be doing here. I will say x plus 4y. Now this is the molar mass into Kf 5.1 into 1000 into W2. W2 is again 5. No, sorry, 1, not 5, sorry. It is 1. Divided by 20 into, now the lowering in vapor pressure is 1.3. So you have two equations. You will get two equations in two variables, x and y. So you will solve those. Basically, if you subtract one from the other, x and x will get cancelled, you will get the answer. So I'm just, if I have just a second, when you get x plus 2y, x plus 2y you will get as 110.87, 110.87, and x plus 4y you will get 196.15. So these two equations you will get. Solve these equations, get the value of x and y that is asked. Atomic mass of A and atomic mass of B. Anyone, any confusion, let me know.
Sir,
Devanshi,
your voice was cracking. Can you repeat it?
yes, Vedant, I can repeat. Okay. From where?
Sir, just now, sir.
Okay. The last one is, I have just substituted the values. Okay. For first case, this is, remember, I am talking about the first case. The first case is you have AB2, 1 gram of AB2 in 20 grams of benzene and lowering in vapor pressure, sorry, freezing, depression and freezing point is 2.3. So here I have obtained the molar mass of AB2 in terms of atomic masses. So I have applied the formula. So here I will substitute all the values. So here it will be x plus 2y equals to Kf is given for benzene 5.1 into 1000 into W2 is 1 divided by W1 is 20 mass of solvent into delta TF is 2.3. When you solve it, you will get x plus 2y equals to 110.87. Say this is first equation. In second case, you again have 1 gram but of AB4. So here you will again apply the formula. MAB4 will be equal to Kf into 1000 into W2 divided by W1 into delta TF. In this particular case, MAB4 is x plus 4y equals to Kf 5.1 into 1000. Again, it is 1 gram of AB4. It is AB4, but it is again 1 gram only. Solvent is same 20 gram and delta TF in this case is 1.3. When you solve, you will get x plus 4y equals to 196.15. This is second equation. Now you can solve these two equations. X plus 2y is 110.87. X plus 4y is 196.15.
Yes.
Okay.
Okay. Sir.
And you will get the value of x and y. Kasak says x will be 25.59, y will be 42.64. Yes, that is the values, that is the answer I have. So your answer is correct. So you will get x, that is atomic mass of A, as 25.59. You should write the atomic as U, unit as U, and y will be 42.64. Next one. At 300 K, 36 grams of glucose present per liter in its solution has an osmotic pressure of 4.98 bar. If the osmotic pressure of the solution is 1.52 bar at the same temperature, what would be its concentration? Now, this particular question can be solved by two ways. But which one you should prefer? You should prefer the one which question demands. And question specifically says there are two conditions given. So in questions, even if it is possible, I'm repeating, even if it is possible to get the answer by applying one formula, you will not use that. You will form two equations, or you will form a relationship with those two equations and then get the answer. Understand what I am saying? Okay. In this particular question, if I apply the simple formula that pi is equal to CRT, okay, you have been asked what is the concentration. C is asked, so C will be pi divided by RT, and pi is given 1.52. R, you know, temperature is given 300. So you could say 1.52 divided by R, and because it is in bar, R will be 0.0831 into T 300. Okay, and you can get the answer. You will get the answer, but you will not use it. The reason is because two conditions are given. So you have to form the relationship and then get the answer. What I mean by that, understand. First, everyone should be clear about that this question can be solved by simple formula. We will apply the first case. First case, we will say, okay, pi is equal to CRT, but I will say it is pi1 equals to C1RT. And in second case, it is pi2 equals to C2RT, because R and T are constant. At the same temperature we are talking about. So T is constant, R is universal constant. So from here, I will say dividing 1 by 2, I will get pi1 divided by pi2 equals to C1 by C2. Pi1 is given 4.98. So 4.98. Pi2 is given 1.52. 1.52 equals to C1. C1 will be given mass divided by molar mass. And we are talking about glucose. So it will be 36 divided by C1 I am talking about. Okay. 36 divided by 180. 180 is the molar mass of glucose divided by C2. C2 again we are talking about. Okay. But in case of C2, we have to calculate, and we will eventually get the same answer here. If we calculate by this method, we will eventually get the same answer, but still you have to do it by this method. All values of R, Vedant, I have explained quite a few times, okay? And these are given in the notes also. I'm just telling you very quickly, R is 8.314, okay, Joule per Kelvin per mole. It is 0.0821 atm liter per Kelvin per mole. It is 0.0831 bar liter per Kelvin per mole, or it is just 2 if you say calorie per Kelvin per mole, approximately.
Okay, thanks.
So from here also, if you calculate the value of C2, it will be approximately same, but this is the method you have to get. So from here, you will calculate C2 and you will get answer as 0.061 m, because this is molarity. You can write mole gram per mole, or you can say mole per liter, or you can say capital M. You can write mole per liter as well. This is the unit of concentration, molarity, or capital M. Okay, now why I say that you should be following this method. In this particular question, by chance, you will get same answer, by chance, okay? But if this question appears in JEE, most probably the value of R, they will not consider as 0.0831. And that is the reason the answer will be different. Because if you apply the direct formula, in that case, you will use the value of R as 0.0831, but the actual value, when these calculations were done, when this experiment was done, R was not exactly 0.0831. So that's why the difference in the answer. But here, because R and R will get cancelled, so you don't bother about R, whatever value is there. You are just following what is given in the question. These are simple points where students make difference. Toppers are from you only. Okay, they don't come from other planet. This is the only thing they remember, these simple points. Now the next one. Suggest the most important type of intermolecular attractive forces in the following pairs. Slightly confusing sometimes, and that's why everyone should pay attention, specifically in, for example, fifth, etc., or second, specifically second one. Okay, if I say N-hexane and N-octane, first of all, you need to be very clear that the force of attraction, if there is no dipole, no polarity difference, okay, means no difference in electronegativities, then dipole cannot be there. For ionic, there should be too much difference in electronegativities. One highly electropositive, the other one highly electronegative. For example, sodium and chlorine, Na plus, Cl minus. That will be ionic. But in this case, N-hexane, N-octane, nothing ionic, no dipole. So it means there will be only van der Waals forces, nothing else. Only van der Waals forces. Now the next one is slightly tricky. I2 and CCl4. Because I said if there is difference in electronegativity, it can be dipole. So then you can say it can be dipole-dipole moment, or maybe dipole-ion-dipole moment interaction. But understand this one. I2 is anyway non-polar because both are same. I. Okay. It is non-polar. CCl4 also the dipole moment gets cancelled because it is tetrahedral form. Cl, 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 Cl. All dipoles are cancelled. So effectively, this is also a non-polar molecule itself. Within molecule, there is polarity, but the polarity is cancelled. Bonds are polar, polarity is cancelled. So this one is also van der Waals forces. And this one is where most of the students make mistakes. Then NaClO4 and water, this one is straightforward, very easy, because NaCl4 will get ionized into Na plus and ClO4 minus. So here it is ion. And water is a polar molecule. So here it is ion dipole interaction, ion dipole forces. One is ionic, the other one is dipole. Yes, correct answer, good. Then methanol and acetone. Alcohol and ketones have hydrogen bonding. Okay. Alcohol and ketones when mixed will show some hydrogen bonding, but not only ketone. So if it is only ketone, hydrogen bonding will not be there. But methanol and acetone will have hydrogen bonding. Then next one, acetonitrile and acetone. And this one is very easy one. Acetonitrile And remember here in this case, you could have considered acetone as dipole because acetone is CH3, COCH3, and this bond is dipole, plus minus. Right? And this OH bond is also dipole, sort of dipole, because here it will be CH3 OH. This end is positive, this end is negative. But remember, hydrogen bond is much stronger than dipole-dipole interaction. Simple dipole-dipole interaction is much weaker than hydrogen bond. So if there is hydrogen bond, you will write hydrogen bond, not a dipole-dipole interaction. And moreover, hydrogen bond is a special case of dipole-dipole bond. Remember that. Kasak, yes, the fifth one you are telling me, right? So if I consider the fifth one, so you should be clear why fourth one I did not say polar and polar. I did not say polar and polar in case of methanol and acetone, though there was polarity because hydrogen bond is much stronger than simple polar-polar bond. Now in this case, here it is CH3, CN. Here it is acetone, so CH3, CO, CH3. Here it is dipole. And there won't be any hydrogen bonding now. And this is also dipole. This one, fifth one is dipole-dipole interaction. This question has appeared as it is not complete one, maybe few parts, 1 and 3rd only, 2nd and 4th only, or 1, 3rd, 5th only. Quite a few times in your exam. So these 5 you need to remember. Very easy marks from here. Few things what I have told you, you have to remember CCl4, the dipole moments are cancelled. In methanol and acetone, though there is polarity, but hydrogen bond is much stronger than dipole-dipole. So you will not write dipole-dipole, you will write hydrogen bonding. Okay, so that's important. Any confusion here? You need to let me know. Any confusion here? Let me know. Next question. Based on solute-solvent interactions, arrange the following in order of increasing solubility in N-octane and explain. This question, similar question, if you see previous papers of JEE, this question has appeared as MCQ. And answer is very easy. Why the answer is very easy? Because you will say polar solvents dissolve polar. So polar dissolves polar, non-polar dissolves non-polar. That's the thumb rule. Okay. Polar dissolve polar. So it means what is N-octane? You need to find out. This is the solvent, N-octane. N-octane is polar or non-polar? N-octane is non-polar. This is just CH3, CH2, 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 CH3, like this. 8 carbons. So because it is non-polar, non-polar will be maximum soluble in N-octane. So you need to find out which one is non-polar and which one is most ionic. Most ionic one will be not at all soluble. The polar will be rarely soluble. Less polar will be more soluble than more polar, and non-polar will be soluble up to maximum extent. So you need to first find the ionic character, and reverse we will follow that. Okay. So here in this case, non-polar, I will say N-octane is non-polar Hence, non-polar solutes will be soluble up to greater extent. So if I say cyclohexane, this one is non-polar. Cyclohexane. And if I consider the difference in the electronegativities, K plus and Cl minus, this is ionic. CH3OH and CH3CN are not ionic, but these are polar. So I need to find out which one is more polar, which one is less polar on the basis of the difference in electronegativities. So if I consider difference of electronegativities in O and H and C and N are very close in periodic table, right? You have boron, carbon, nitrogen, oxygens, okay, fluorine, like this. So the difference of electronegativities here is not very high. So less difference. But between oxygen and hydrogen, there is much more difference in electronegativity. So here, higher difference in electronegativities of O and H, hence more polar. Here in this case, the difference in electronegativities, so you will say smaller difference in electronegativities of carbon and nitrogen. So this is less polar. So you will arrange them for solubility, you will arrange them from most polar to non-polar. Most polar will be least soluble because Rn octane is non-polar. N octane is non-polar, so non-polar will be most dissolved, most soluble. So if I write in increasing order, okay, in increasing order of solubility, this one will be most soluble, so this will be in the last. Cyclohexane. Then the most ionic will have least solubility, so KCl will be in the beginning. Then more ionic will be less soluble, so more ionic is CH3OH. You say more polar, not more ionic. And CH3CN is less polar, will be more soluble. So the condition you need to remember, N-octane is non-polar, hence non-polar solutes will be more soluble. So this is non-polar, this is less polar, this is more polar, and this is so high polar that it is ionic. Ionic one will be barely soluble in non-polar compounds. That's why this is the trend. These type of questions are very much common in NEET and JEE, so everyone should be clear about it. Any confusion, anyone, let me know. Next one. Amongst the following compounds, identify which are insoluble, partially soluble, and highly soluble in water. Again, similar question. So you will say the ionic will be soluble in ionic, or you will say polar will be soluble in polar, non-polar will be soluble in non-polar. We have to talk about soluble in water, and water is polar. We have to write in terms of insoluble, partially soluble, and highly soluble. It means If the compound is not so polar, then we will say partially soluble. It is polar, but weakly polar, we will say partially soluble. If it is non-polar, we will say insoluble, because non-polar will not be soluble in polar. Water is polar. And if it is polar, we will say soluble. So talk about phenol. Phenol will be like this. Now, though OH group is there, OH is actually alcoholic group, but here it is on arene. So due to hindrance, and remember, I will be talking about the same thing in one other also, okay, option in same question. If hindrance is higher here, then the hydrogen bonding will not be great. So the other one I am talking about, think that if you have AA interactions, B interactions, the solubility will be when the interaction between AB and AB are greater. So it will be soluble if these interactions are greater, these interactions between A and B. Okay. So what happens in case of phenol and water, though OH group is there, but due to the aromatic resonance, obviously, and also due to bulkier group here, the possibility of hydrogen bonding is very less. So it will be soluble, but partially soluble. We can't say it is insoluble because there will be some hydrogen bonding. So it will be soluble, but partially soluble. We will say partially soluble. Phenol. Toluene is like this. Is there any possibility of any hydrogen bonding? Is this molecule polar at all? So this molecule is not polar. There is not much difference in electronegativities anywhere. Carbon and hydrogen have very similar electronegativities. So this is non-polar. And because it is non-polar, it will not be soluble in polar. So it is insoluble. Toluene will be insoluble. Now come to formic acid. Formic acid is HCOOH. And this is actually HCOOH. And this oxygen forms hydrogen bond because this is electropositive, this is electronegative. This electronegative forms hydrogen bond with this one. So there is some extent of hydrogen bonding, but there is no hindrance at all. In this case, there was hindrance from the bulkier group. In this case, there is almost no hindrance. So the extent will be much greater than phenol. So we will say this one is soluble. Formic acid will be soluble. And the reason is there will be hydrogen bonding and almost no hindrance, very negligible hindrance. Same concept you will be applying in other molecules also. So just try to apply, try to remember. You will be getting answer very easily. Then the next ethylene glycol. In ethylene glycol also, you have CH2OH, CH2OH. There are two OH groups here. Both will form hydrogen bonding with water. Both will form hydrogen bonding with water. It means it will be soluble. And again, negligible hindrance. CH2, CH2 are very small groups. Then this one is important, chloroform. And this is where students make mistake. Okay. Chloroform is CHCl3. And first I am getting answer. I want answer from you, everyone. Tell me the answer. Once you tell me the answer, I will be asking to mark the presence again.
Sir, could you repeat the question once again?
My question is for chloroform, whether it will be soluble, partially soluble or insoluble in water. What logic you apply, I will ask later on. But first tell me, what do you think? Okay, Kasak, correct. I will ask for the reason. Ariman, no, that is not basically the case. Tanishid, no. Samad, no. Vedant, no. Okay, and that's why I'm asking, because you need to remember. You need to remember the reason, a specific reason we have here. Okay. Most of the times this question appears and students make mistake. This is the logic I will be talking about here. This is the logic. Any substance is soluble if, or partially soluble, if the interactions between A and B are greater, or attractive forces in A and B are greater than AA and BB, then we say yes, it is soluble. If yes, something happening, we will say partially soluble. If only few, this one is almost equal, we will say partially. But what happens in case of CHCl3? Devyansh, no. Pranav, okay, yes, Pranav Singh. Before I explain, I will ask Pranav and Kasab. Pranav, tell me, why do you think it is insoluble? Pranav, or that was just a guess? Answer is correct.
Sir, your voice was breaking up, sir. What were you saying?
My question is, Pranav, why do you think the chloroform is insoluble in water? Answer is correct.
Sir, I think, sir, because it forms layers.
No, no. But Kasak has given me correct answer. The reason is simple. Reason is simple, and try to understand. It is different, but it is simple. In water, in CHCl3, it will be like this. CH Cl, and water will be, HOH, and there will be hydrogen bonding. So there is hydrogen bonding in case of water. And if you consider whatever I said soluble this one, I said soluble this one, both were forming hydrogen bond. So try to understand and remember this logic. It will be soluble if it can form hydrogen bond. It's because in water there is already hydrogen bond. So that is first case, which is not happening here. In this case, if you see, chlorine cannot form hydrogen bond. Fluorine, oxygen, nitrogen can form hydrogen bond, not the chlorine. So there is no hydrogen bond. This is first case. Moreover, when it is CHCl3 and CHCl3 molecules, due to symmetry, they have dipole-dipole interaction. They have dipole-dipole interaction here. So within chloroform, there are dipole interaction, but it cannot form or cannot have dipole-dipole interaction with water, because water already has hydrogen bond. It already has hydrogen bond. So first this hydrogen bond should be broken for that. But the energy is not sufficient to break this hydrogen bond. So first of all, there is hydrogen bonding in water, which is not present when we mix chloroform with water. So hydrogen bonding is not there between chloroform molecule and water. Moreover, there is dipole-dipole interaction before mixing chloroform and water. There is dipole-dipole interaction in chloroform, but this dipole-dipole interaction cannot exist between the chloroform and water molecule because water molecules are attached with one another with hydrogen bonding. So they are not free. So chloroform is actually insoluble in water. Now tell me pentanol. Pentanol. No one will disconnect. I know that the time is over, but we started late. Yes, Devyansh, correct. You remember when yes, Hariman, correct. You remember when I explained first one, I said hindrance. So if there is OH, there will be hydrogen bonding. Remember in pentanol, you have hydrogen bonding because it is CH3, CH2, 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 OH. So there will be hydrogen bonding of this alcohol and water, but because this is a bulky group, that's why the water molecule cannot attack this OH, cannot come very close to this OH for quite a few times. So that's why the extent of hydrogen bonding will be less than as it was between the water-water molecules. So it will be partially soluble. Hydrogen bonding will be there, but not up to that much extent as it was already.
Sir,
That's why
because of
partially
the
soluble.
carbon, sir, it won't make a group.
Because of?
Sir, the carbon compound.
Come again, repeat your statement.
Sir, is it because of the 5 carbon chain in it?
Yes, yes, it is because of 5 carbon chain. Yes, it is very big group, alkyl group attached. So alkyl group is very bulky. That's why hydrogen bonding, it will create hindrance. Hydrogen bonding, extent of hydrogen bonding will be less than what it was in water molecules. So partially soluble. I will do one more question. After that, you have to mark presence. And this one is
Can you
simple.
please show the previous slide?
Yes. Okay.
Yes.
This one is very easy question. If the density of some lake water is this much and it contains 92 gram of sodium ion per kilogram of water, calculate the molarity of these ions. And this one is simple because molarity is simply the number of moles divided by the volume of solution in liters. So yes, Vedant, good. So we will find the volume. So it is 1 kg of water. Okay, 1 kg of water. So that's why we will find the volume of 1 kg of water. And then we will get the number of moles of sodium ions. So you will say number of moles of sodium ion will be given mass divided by atomic mass of sodium, which is 23. So you will get 4. And volume of solution. Okay. Obviously, I am neglecting the mass of this one. You can add, okay, but suppose you add. So you will say mass of solution. I'm not doing approximation then, even then. Mass of solution will be 1 kg of water, 1000 plus 92 grams. So 1092 grams. So you will say volume of solution will be mass over density. So it will be 1092 divided by 1.25. And remember here you will get in milliliters because it is 1.25 grams per ml. It will be milliliter. You will have to convert it to liters. Then you will say molarity equals to number of moles divided by volume. So it will be 4 divided by 1092. And obviously it will be equal to 1092 divided by 1250. You will get the answer.